Okay, so with 8.2, this is inverse. Now they do add one other little name to inverse, one other option. We're going to talk about it, but it's still exactly the same thing. With inverse, they also call it, sometimes they call it the reciprocal functions. And they talk about reciprocal functions. They're basically the same thing as the inverse functions when we're going through these. So when we're talking about the graphs on these, let's show you the graphs of what we have here. Because that's the one thing we didn't do. Because we either have, if we do a function, sometimes they're going to talk about functions. So we've got the f parentheses x equals k over x. We're going to flip-flop back and forth from being functions to equations, so we're also going to have y equals k over x. So whether you see either one of those two, it's the exact same graph. The one catch with this one is, they always put one little restriction here, is that what happens if, all right, let's have a flashback here. What happens if you take this thing and you divide, let's say the k value is 6. What happens if you take 6 and divide it by 0? Get the error message, right? So the one restriction they put on this one is that when you're doing this, the x value cannot be 0. Because if you plug 0 into that function, it doesn't give you a real answer. It says, all right, this is not going to work. This is not going to be something we're talking about here. And we have two choices. Either our k value is going to be negative, or the k value is going to be positive. Okay. And again, to get the k value out of this equation, we'd have to go back and multiply x times y. So now, think about this one. If, let's say we went to an ordered pair that was up here, up in the first quadrant. What's the x value going to be up here, positive or negative? Quadrant 1, the x is positive, right? What about the y value? It's also positive, right? So what happens if you multiply or divide two positive numbers? Get positive, right? We're looking for the k to be negative. So any number we do up here is not going to work. So if we go back to the second quadrant, back here, the x is negative, the y is positive. What happens if you divide a positive and a negative? You get negative. So that would give you the k value that's negative. So here's what we're going to do for this. That basically everything in here would be negative. If we go down here, what happens if we divide two negatives? We get a positive, right? And then over here, if we have one positive and one negative, we're back to the negative. So here's the basic shape that we're going to have for these. And we'll come back and show you the details on it in a second. But if the k value is negative, it's always going to look something kind of like this. And then the other part of it would be over here. Because we said that was the only way you could get a negative, was that up here it was positive, down here it was positive. When we multiply and divide those numbers, that was our negatives. And that's going to be the basic shape. Now again, we'll come back and actually plug in a specific number to show you that one. If k is positive, well, we said that was here, and then also here. And that's our only two choices of graphs when we're doing these. If we're doing inverse functions, whether if it's k over x, or whether it's an equation where it's y equals k over x, or whether it's a function, so it's f of x equals k over x. They're the exact same graph. It's just written one of two different ways. All right, now here's where we're going to throw one little bit of new vocabulary at you. And actually, I think we may have already, didn't we talk about this? Did we talk about asymptotes? No, we talked about axis of symmetry. I was thinking about that from back in chapter 4. So asymptote, here's what an asymptote is. an asymptote is a line. It's almost like the axis of symmetry, but instead of it being in the middle, this is a line that a graph touches. Sorry, that a graph approaches. But never touches. As x increases or decreases. And that goes back to this over 0 part, that if we have those lines that's here, that if you get really close to the top or bottom of this part of it, when x is getting really increasing far out or x is decreasing a lot, that if we keep chasing this x value out here, we get really close to 0, but we never quite get there. Same thing for this one. We can get close to x, and the x keeps going and going and going. It gets really close to 0, but it never gets there. Same thing back here. We could do the same thing for this part. And you could put the same thing for y. So as x increases or as y increases or decreases. So you just go back and put ditto marks there and be okay. Okay, I know asymptote's a funny sounding word. But you never quite get there. And you're going to have two asymptotes. And again, y'all get to have your notes on this test that we're going over. So, because we're out against fall break here, so that should be a good thing to have when we're going in here. Should be Thursday. Okay, so the first thing is we're going to call it a VA because it's a vertical asymptote. That way, if we're talking about different things, we need to kind of shortcut on the notes. We can do that. So you have a vertical asymptote at x equals 0. And then we're going to have a horizontal asymptote at y equals 0, so that one we'll call it an HA. Okay. Now, here's a question. We're going to go back to way back to like chapter 1 and 2. If we're talking about the x values, was that domain or range? That was domain, right? So for this one, they're going to ask you to go back and talk about domain and range. So for this one, your domain is going to be everything except for, so it's all real numbers. The only thing we're going to skip over is this x equals 0, because if we plug in 0 into this equation, it's going to mess things up. So it's all real numbers except for x equals 0. And for horizontal asymptotes, because we're talking about the y values, then that's going to be the range. And it's going to be the exact same answers for this one. It's going to be all real numbers except for y equals 0, because we've got to leave that one number out. Okay, so that's our basic setup. Now, here's where all this stuff ties together, and this is where we'll show you like one basic little example of how you have to do. And not going to ask you to do this on most of them. Most of the time, it's going to be multiple choice, so you're not going to have to do a whole lot of graphing here. And there shouldn't be that many questions overall that you have to graph, but just enough to make sure we got just the basic idea of it. Alright, so let's do f of x is equal to 6 over x. Now, again, when they do f of x, you can think about that is really the same thing as y equals 6 over x. So whether they show you this one or this one, it's the exact same graph. Okay, so all we're going to do is, let's start with 1. And we're just going to plug it back in and see what you get. What's 6 divided by 1? 6, right? Okay, do the same thing with 2. 6 divided by 2 is 3. There you go. And we're going to plug in 3. What's 6 divided by 3? 2, right? Now, if you plug in 4, if you do 6 divided by 4, that's 1.5. More than likely, if you get decimals, don't worry about that one, because there should be enough other numbers around it that you can have whole numbers. So you can use that if you want to, but most people don't like decimals, so let's just kind of skip over that one for now. If you need it, you can come back to it, but let's see if we can do the whole numbers. If you did 5, that would also be a decimal, because it would be 1.2, so we'll skip over it. But 6 would be the next number that would work evenly, so 6 divided by 6 is 1. There you go. Alright, and all you're going to do is you're just going to graph those points. This point's at 1, 6, so if we go over 1, up 6, be about there. Next point's at 2, 3, so over 2, up 3. Next one's at 3, 2. We're skipping 4 and 5 because they gave us decimals. When we get to 6, that was 1. Okay, and if you connect the dots, gives you a line that looks something like that. And if we go back up here real quick, this was our k value was 6. 6 is positive, so it falls into that graph. So it looks something like that. Okay. If you want to make it for the other part, just change these numbers. Change that to a -1. What's 6 divided by -1? Just -6, right? So all you're going to do then is go back and change these numbers so they're also negative. And then you've got the exact same graph there. You've got -1, -6, -2, -3, -3, -2, and then -6, -1. And then you have the exact same graph that would go that way. Yeah. But the main thing is to know on these that if they give you this graph that this top number is positive, it's always going to be top right, bottom left. If that had been a negative, it would have been these two corners. Okay, and then the one last thing that we'll do. Oh, now if they ask you for these, for this one, you would have a vertical asymptote at x equals 0, and you'd have a horizontal asymptote at y equals 0. And same thing before. If they ask you about the domain on these, the domain would have been all real numbers except for x equals 0. The range would have been all real numbers except for y equals 0. All right, and the only other thing that we'll look at in section 2, which again, we're not going to ask a lot of these. It's mostly just a couple of them just to make sure you've got the basic idea. Is they're going to ask you, all right, well, what if we take the same basic inverse function that we have here where we've just got 6 over x or -6 over x or something like this. And they're going to say, all right, well, let's take this same thing we have here and let's expand it where we're going to have more numbers other than just this one variable that's up here. And so this is where they change it just a little bit. They're going to talk about translations, reflections, and then you also could do a stretch or a shrink. All right, does anybody remember vaguely, and then don't write this part down because this is just flashing back. Do y'all remember when we did quadratics? When we graphed those, that the basic shape we had was a times x minus h squared plus k. Y'all remember that at all? Where the a value told you if it was up or down, right? These two numbers were the vertex, and they would tell you where this thing would be. The h value is always the opposite direction, and the k value is always the vertical direction in the normal space. Well, this one's almost exactly the same way, but the thing they're going to do different is it's still y equals a, but instead of being the x on top, they put the x on the bottom along with the h, and this k is going to go outside. So they're taking the exact same thing we did with quadratics when we had the curve back here. Well, now we're going to do it with the inverse. So instead of the x minus h being squared, now it's just in the denominator. Okay, so when we're doing this one, we're going through with the parts over here, the h and the k. That's coming out of everything that's here. So the h, that is your horizontal movement. And just like when we did the quadratics, it's going to be in the opposite direction. All right, actually, let's put the k down here so we get a little bit more room. So h is the horizontal movement in the opposite direction, and k is the vertical movement. And again, we'll say that's in the normal direction. Okay, and the a part of this one, it's kind of like we did back up for this one, that it's going to, instead of it being up and down, this a value tells you which corners you're going to be in. If that a value on top is positive, we're here and here. If that a value is on top is negative, we're going to be here and here. So that's where they change it. That's the difference between when we did inverse function, this is a reciprocal function. They just add more stuff in for a reciprocal function. Okay, and for the a value, if the a is greater than 1, that's a stretch. And if a is somewhere between 0 and 1, then that's a shrink. Okay, and if they do make that top value what we'd look at before, if they make it a negative, they just say that's a reflection over the x-axis, but we just know how the basic setup is going to be there. But again, really that a value tells you which corners you're using. So they may call it a reflection, but we still know that it's basically just kind of marking which part we're going to graph when we go through this thing. Okay, now here's where I'm not going to, if they give you, let me just show you one problem, because if we can do one problem, then everything else should be fine. That I'm not going to ask you to graph like we did up here where we graph, all these different points and do this. I'm just going to look for a couple of basic things when we're going through the graphs on these. If we had plenty of time and we had, we could do a 3-hour test, we could do that, but we're not doing a 3-hour test. This is, just a normal class time. So let's do this. Let's do y is going to equal. Let's do -4 over x plus 6 minus 7. Okay, and this one might actually be a little better because you can actually see the real numbers on this one. Whatever number you pull out of x, this is where you have to change the sign. So we've got a positive 6, change it to a negative 6. This one, you keep the sign the same. So keep the same sign. So that one is negative 7. And just like it was now, before that was the vertex. This one, it's not really the vertex. But this is almost like our new ordered pair kind of thing that we have here. That really, for this part of it, this would be your vertical asymptote. So you got x equals negative 6, and the y would equal negative 7. This is your vertical asymptote. And this would be your horizontal asymptote. So when they give you this equation, they're giving you the two answers. Whatever number is with the x, that's the x equals number, so that's the vertical asymptote. You just change the sign. Whatever the number is that's out here, that's the y value, so that's your horizontal asymptote. And the negative 4 basically just tells you which parts of the graph you're going to shade in. Okay, now if there was nothing else here, if it was just negative 4 over x, we would start at 0, 0. But these two numbers tell you, all right, now we're shifting this graph. Instead of starting at 0, 0, now we're going to go to negative 6, negative 7, and we're going to start down here. Oh, sorry. So negative 6, 1, 2, 3, 4, 5, 6, and we're going to go down 1, 2, 3, 4, 5, 6, 7. And then basically you're going to start a new, it's almost like an XY axis here, that you're going to go back and draw a dashed line here and a dashed line here. And those dashed lines are your vertical asymptotes. So they're going to show those with the dashed lines. And it's basically, it's almost like it's a new XY axis is really what it's like. Okay, now, and here's where I'm not going to get so much in the details. All I'm going to want you to do is move this number here into here. So we've got a new dot right here. And if it's negative on top, that means we need the graph over here. And over here. That I'm not going to ask you to plug in all these different points. All I want you to do is just be able to move this graph up or down or left or right, and then just draw another cross, basically just draw a T right through the middle of it. And know that if it's negative, you're here and here. If that had been a positive 4, we'd have been here and here. Okay. And that's, again, you're not going to have to plug in all these different points and do all these different things. That's basically it. Just know that you can put the graph, and it should be multiple choice when you're going through these, because there's too much work to kind of have you go back in and do the rest of it. The only other thing they might ask you to do back here is that they might ask you for domain. Well, it's the exact same thing we've got right here. This is going to be all real numbers except for negative 6. And same thing for this one. If it's the range, it's all real numbers except for negative 7. Yeah. And everything's going to just spin off those 2 points they give to you when you're going through this. So whatever this number is, you just change the sign of it. This number stays the same. That's the x value and that's the y value.